Good afternoon. Today we are going to learn the laws of exponents. But firstly, we have to learn how to write our exponents. This is the way that we write our exponents. Our exponent has to have A as our base and B as our exponent, okay? Yes. We have to have a base, and our exponent does not sit exactly on top of our base. It sits slightly to the right, like I did here. It sits slightly to the right, and it's our exponent, right? Together, the base and an exponent, we call them a power, right? We call them a power. This is our exponential form. When we talk about the exponent, it means we have a base and an exponent. So, now we have to get into our laws of exponents. The first law that we have a product law. What is a product law and what does a product law say? I hope we all know that product means multiplication, right? Yes. Product means multiplication. So our law says when multiplying the same base, we add the exponents. It says when multiplying the same base, we add our exponents. That's our law in words. And our law in mathematical expression, we remember when we say mathematical expression, we deal with numbers and alphabets, right? We don't deal with words. Mathematical expression deals with numbers and alphabet. And our law in mathematical expression says we have A to the exponent of 2 multiplied by A to the exponent of 3. This is the first part where it says when multiplying the same base. We have A and A. So we are multiplying the same base. And the second part it says we add the exponents, right? So we're going to say A to the exponent of 2 plus 3. This is our exponent. This is our exponents. So we are going to add them. We are going to add our exponents. So we have A to the exponent of 2 plus 3, which is going to be A to the exponent of 5. So it's going to be A to the exponent of 5. I'll also have a few examples here. The first example says we have 2 to the exponent of 2 multiplied by another 2 to the exponent of 2. We firstly have to find that we have to see that we are multiplying, right? And what are we multiplying?
The same base.
So we have 2 as our base. And when we multiply the same base, we have to do what? To add our exponents. So we're going to say 2 to the exponent of 2 plus 2, which is going to give us 2 to the exponent of 4, which is going to give us 2 to the exponent of 4. And 2 to the exponent of 4 is equal to
16.
The second example, we have q to the exponent of 3 multiplied by q to the exponent of 4. So we're going to add our exponent because we are doing what? We are multiplying the same base. We have q to the exponent of 3 plus 4, which is going to give us q to the exponent of, what is 3 plus 4? 7. 3 plus 4 is 7. It's going to give us q to the exponent of 7. That's our product law, which says when multiplying the same base, we do what? We add the exponent. When we multiply the same base, we add our exponent. Now we are moving to the second law, which is a quotient law. What does the word quotient mean? Division. It means we are dividing. Quotient means we are dividing, right? And our law says when dividing the same base, we subtract the exponent. When we are dividing the same base, we subtract the exponent. That's our law in words. And our law in mathematical expression says we have A to the exponent of 10 here divided by A to the exponent of 5. Which is going to be A to the exponent of 10 minus 5. What is 10 minus 5? 5. So we're going to have A exponent of 5. I also have a few examples here. We have 3 to the exponent of 7 divided by 3 to the exponent of 5. What are we doing here? We are dividing. We are dividing the same base. And when we divide the same base, we have to
Subtract the exponents.
So we're going to say 3 to the exponent of 7 minus 5. What is 7 minus 5?
2.
So we're going to have 3 to the exponent of
2.
What is 3 to the exponent of 2?
9.
Using your calculator, you find that 3 to the exponent of 2 is equal to
9.
Second example here, we have 10 to the exponent of 15 divided by 10 to the exponent of 12, which is going to give us 10 to the exponent of 15 minus 12. Minus 12, because we are doing what? We are dividing. And when we divide, we need to subtract the
Exponents.
which is going to give us 10 to the exponent of 3. What is 10 to the exponent of 3 using your calculator? 10 to the exponent of 3 using your calculator. 1,000. It's 1,000, right? We have 10 to the exponent of 3 is 1,000. When we take a look here, our product law and quotient law, they're kind of similar. The product we are multiplying and we add. When multiplying the same base, we add our exponents. But the quotient we are dividing, and when we divide, we do what? We subtract
The exponents.
They're just a mirror of one another, okay? So the third law that we have again is the power to a power law. A power to a power law. This one is like it. It just says we multiply the exponent. All we do here is to multiply the exponents. Let's say we have inside the bracket a to the exponent of 3, close bracket to exponent of 4. What we have here in common is that inside our bracket, we have an exponent of 3. And outside the bracket, we also have what? An exponent. We don't have the same base or whatever, but we have exponents inside and outside our bracket, right? So what we do when we're dealing with this law, the law says we just multiply the exponent. You write your base, which is a, to the exponent of 3, right? It's a to the exponent of 3, and we're going to multiply it with the exponent that is outside the bracket, which is 4. It's going to be a to the exponent of 3 multiplied by 4. What is 3 multiplied by 4? 12. We're going to have a to the exponent of 12. A to the exponent of 12. I also wrote a few examples. Example number 1, we have open bracket b to the exponent of 7, close bracket to the exponent of 2. So what are we going to do? We are going to multiply
The exponents.
the exponent inside the bracket multiplies the exponent that's outside the bracket, which is going to be b to the exponent of 7 multiplied by 2, right? And what is 7 multiplied by 2? 14. We're going to have b to the exponent of
14.
The second example says 2 to the exponent of 5, close bracket, exponent of 3. We are also going to multiply the exponents. We're going to say 2 to the exponent of 5 multiplied by 3. What is 5 multiplied by 3? 15. 2 to the exponent of 15 is equal to 2 to the exponent of 15 is equal to 32,768, right? It's 32,768. This is how we solve our power to a power law. We just multiply the The what?
The zero law.
The zero law says any number or variable to the exponent of 0 is equal to 1. Any number or variable to the exponent of 0 is equal to
1.
What is a variable?
Is a
A variable.
is a alphabet.
A variable is an
Alphabet.
Any number or any alphabet to the exponent of 0 is equal to
1.
This is our law in mathematical expression. We have a to the exponent of 0 is what?
Is
equal to
1.
equals to 1. And we have 15 to the exponent of 0, which is equal to 1. Any number or variable to the exponent of 0 is equal to 1. I also gave few examples here. We have x to the exponent of 0. What is x to the exponent of 0?
1.
What is x to the exponent of 0, Ito?
1.
X to the exponent of 0 is equal to 1. The second example B, we have into bracket p q close bracket to the exponent of 0. What is going to be our answer? 1. Our answer is going to be 1. And let's say we have 15,000 to the exponent of 0. What is going to be our answer? 1. When using our calculator, 15,000 to the exponent of 0 is equal to 1. 10 to the exponent of 0 is equal to 1. Any number, doesn't matter how small or big the number is, any number or variable to the exponent of 0 is equal to 1. Any number or variable to the exponent of 0 is equal to 1. Thank you very much.